Good afternoon, and thank you for joining this second innovation webinar organized by Smart2B. My name is Fulvio Bernardini, and I oversee communication and dissemination activities for the Smart2B project. Smart2B's innovation webinars are a series of events that started last July and will take place until November 2023. These webinars have multiple goals. First, give visibility to the European Commission's initiatives for energy transition. Secondly, deepen the technological challenges related to the concept of smart building. Finally, to spread information about the results of the Smart2B project. Today's webinar will focus on the Smart2B's project devices, which allow the connection of different energy systems to upgrade the smartness of buildings. Marco Martellacci of Enerbrain, which is also a partner in the Smart2B project, will guide us in this topic. The webinar is also an opportunity to learn more about the collection and analysis of smart meter data and discover a real case scenario in which data are exploited to better understand how people use energy and learn about their preferences and in real life. We will do this with Bert Lutje-Berenbrug of Net2Grid and Rui Martins of the Smart Energy Lab. Given the shortness of the speeches, the Q&A session will take place at the end of the last speech. You are, however, invited to share any question during the webinar through the dedicated chat. I will collect the questions and ask them to the speakers during the Q&A session. In case you would miss part of the event or you intend to share it with colleagues and friends, please note that the session will be recorded. The video will be made available in the next few days. I therefore pass the word to the first speaker, Marco Martellacci. Marco is the co-founder of Enerbrain, an Italian company founded in 2015 to reduce energy consumption and deliver better air quality and comfort in buildings. He will introduce the devices layer in the Smart2B project. Please, Marco.
Thanks to all. Could you see my screen?
Yes, no, at the moment. Yes.
Okay. Building, as you know, building account for over 40% of global energy consumption and 36% of European CO2 emission. The Smart2B project aims at upgrading smartness level of existing building through control of legacy equipment and smart appliances, implementing interoperability in a cloud-based building management platform, and creating a user-centric ecosystem that empowers citizens by simplifying equipment and device control, providing information about overall energy performance. With Smart2B, we have developed a set of devices to upgrade the smartness of residential and non-residential buildings. We started from IoT sensors to monitor the environment condition and the electrical consumption of the HVAC system, because to know what happens in the building is the first step to perform simple and effective actions that upgrades the smartness of the legacy equipment. Then we developed a gateway that can act as an intermediary between the intelligence in cloud and the device layer in the building, transmitting the efficiency logic to the building, making it smart and more sustainable. Sense is the first core innovating in the project. Sense is a wireless sensor that measures temperature, relative humidity, and CO2. No wiring is required for its installation. The sensor is pre-configured and ready to send data to the platform. Connectivity is guaranteed by LoRa. This sensor allows us to know what is happening inside the building and to receive feedback on how the building is responding to a specific temperature set point. It's important also to know that the PCB is designed to host other types of sensors, VOC, ambient lights, extreme temperature probes, etc. The second device we developed in Smart2B is a portable device to measure air quality, and so temperature, relative humidity, and CO2 concentration. It gives you live feedback on the CO2 concentration in the environment, from 0 to 5 flashes, depending on the level. So, for example, if the CO2 is good, we have one flash to measure 600 to 800 ppm, and so on. The emitter measurement panel allows the monitoring of power and the consumption of a single phase and 3 phases electrical consumption. The emitter includes a modem and data SIM. We equipped the emitter with a Teltonica gateway to provide stable and efficiency GSM Wi-Fi Ethernet connectivity. The other key innovation we developed in Smart2B is the gateway. The problem we addressed was to create a retrofit solution in a non-residential building where it's necessary to have a wireless sensor and actuators, since to cable and connect everything in an existing building would be not possible. Also, it was important to avoid a single point of failure. Therefore, we worked on a gateway to be split between the cloud and the device layer, where the device layer communicates independently to the cloud, and the cloud-based gateway brokers the communication between platform and device. And at the same time, the device-based component allow to communicate with the edge modules. Our gateway is divided into 2 main components, cloud and device. Cloud gateway, it is developed with the AWS cloud services, and it's mainly used to collect monitoring data and also for to provide an environment for simulation and dashboard visualization. Gateway device is the N-brand gateway that resides on the nodes. The node is our actuators, and where we implemented the edge modules. In this actuator in nodes, we added 2 containers. So we have finally 3 containers. The firmware containers, where originally is all the firmware that is composed of the actuators, the broker containers that is able to communicate with the other 2 containers, and finally the edge container, where contains the data and the library and the code to operate in edge computing mode. The container firmware has not been updated, so we maintain the original container. We decided to implement this architecture on the edge because in the hypothesis of a communication failure, we wanted to guarantee that the node give an equivalent command to the HVAC system. The edge modules remains silent as long as the cloud algorithm communicates correctly with the device layer. Should the communication experience a failure, the safety control activates and elaborates on the edge the command to be given to the actuator. To elaborate the correct command, the device intelligence relies on a model predict control to define an optimal strategy and choose the command that is in normal condition will be given to the actuator. What have we achieved? New device for a better energy monitoring, building a new architecture to bring intelligence on board on the device, granting scalability and flexibility to the solution. design and testing in a simulation of a control algorithm based on the advanced control strategy. Thank you.
Thank you, Marco. Now it's time for Bert Luthier-Berenbroek to introduce how Net2Grid unlocks value from smart meter data. Bert started Net2Grid 10 years ago with a vision that access to real-time energy data is a necessary piece of the puzzle supporting the energy transition. Please, Bert.
Yeah, thank you very much. So at Net2Grid, we focus on unlocking the value from smart meter data. And we basically look at smart meter data from different granularities. We look at the data that DSOs in Europe are collecting already from smart meters for billing purposes. So there's no additional hardware required to derive data from meters and we turn that data into value. And we look at real-time data, where we capture the real-time data on the hand port of meters and stream real-time data with a 1 second granularity into the platform. We have created services that turn data into value in 3 different value buckets. So first of all, we provide customer intelligence. Second of all, we provide customer engagement. And then lastly, we provide a forecast booster. And in this presentation, I'll cover the different value buckets for you. So the customer intelligence service, it provides a 360-degree overview of the customer. It can be used for marketing campaigns. It can be used for CRM systems to understand better who the customer is without an interaction of the customer. It's just based on an analysis of the consumption data. The second one is a customer engagement service where we use smart meter data to create value and to create a more valuable interaction with your customer, allowing you to help customers understand their energy consumption and generate actionable insights. And the last one is a forecast booster where we use bottom-up data to improve the forecasting systems and to boost the forecasting systems the energy retailers are using today. Basically, what we do with the data is we create a digital twin. We create a digital twin of a consumer's house just by capturing the data collected by smart meters. In most cases, these are 15-minute load curves captured once a day, together with the weather data of the location of the customer. And with the data, we identify the energy assets the customer has installed behind the meter. Because knowing how these energy assets operate, what size they have, what are the usage patterns, are very important in managing the grid and are very important in offering bespoke services to those customers. We map the type of home the customer is living in, and we map the type of family the customer has and what the behavior patterns are of that family. So marketing campaigns can be performed much better, and we can increase the conversion rate of marketing campaigns. Now, how we do this is based on our disaggregation model. We have created disaggregation models that work on different types of data. The first model is working on real-time data. It is recognizing appliances, just like the human eye is recognizing buildings in the skyline of Paris. We use the 1 second highly granular power curve to recognize appliances, and we create custom models per house in order to detect appliances with a more than 90% accuracy. We use this data which is highly accurate, as extra information to train our machine learning models that are working on the 15-minute data. There are a lot of companies that try to build machine learning models on smart meter data, but they all struggle to reach a decent level of quality. We have achieved a very high level of quality on smart meter data because we can train our models with additional information that we derive from the real-time data. And that allows us, for example, to derive from smart meter data the exact solar production for each day, even without an interface to the inverter, or to derive, if a customer is using an electric vehicle, the information about the EV charging type. What type of charger? Is it a level 1 charger, a level 2 charger? That kind of information is important for utilities to plan their business. The customer engagement service is operational on an API. Most of our customers create their own front end on top of our APIs, but the combination of our APIs and microservices provide a very engaging customer journey that can be implemented and that is used by many different energy retailers. We noticed that our energy retail customers are obtaining a net promoter score of 60, which is incredibly good for an energy retail service. If you imagine that companies like IKEA get an NPS of 40 and companies like Amazon, their retail services with a lot of focus on customer happiness, create a net promoter score of 60, then for an energy retailer, 60 is really good. We observe a 40% reduction in churn and a 3 times increase of the digital self-serve, which is really because of the more useful service that disaggregated data insights can offer you. And through the increased digital self-serve, the cost to serve, so the reduction of service calls, is about 60%. The data is used for customer intelligence as well, so we can fuel a CRM system like SAP or Salesforce with more information on the customer, and with the data we can fuel a next best action. So if a customer calls a call agent, we can provide information to the customer that generates an offer to the customer that is really useful and leaves the customer as a happy customer after the support call. Then the last value bucket is forecasting. We are not replacing the forecasting systems of our utility customers, but we are improving and boosting the forecasting systems with a bottom-up approach where we correct the growing error that is caused by EV and solar. Most forecasting systems that the energy retail customers are using is based on top-down forecasting. And the uptake of EV and solar is generating a growing error. Our bottom-up approach is correcting that error, and that helps energy retailers in the next day forecast, and also if we have access to real-time data in the intraday forecast. Our service also offers simulations and predictions. I already mentioned marketing campaigns. Through marketing campaigns, we can analyze the solar capacity and calculate what would be an ideal battery size to offer customers in order to increase the conversion rate of marketing campaigns and make them personal. But we can also, in the customer journey, simulate, for example, solar panels. So we can simulate what the effect of a solar panel investment would be on the customer's consumption, which makes the investment really personal and makes it easier for the customer to really understand the earn back time of the investment, because it is a shift from operational expense to capital expense. So in a nutshell, why we are unique. First of all, we are a one-stop shop. We offer both the software services, but we also provide B2B hardware. We are offering services, disaggregation services on data of all granularities, so both real-time and 50-minute smart meter data. We have the largest ground truth database in the world. We have more than 50,000 individual appliance events that we use to train our models. And we can prove that our disaggregation models are 90% plus accurate. And we have a global reach. Our services are being used in Europe, Australia, and the US, and our models are operating in these different regions. And last of all, the technology is proven. We've been around for more than 10 years. We have multinational customers like E.ON, ENGIE, EDF, EDP that are using our service in multiple countries for more than 6 years. If you're interested to have a look at our demo, the QR code gives you access to a demonstration of our service on your own mobile phone. Thank you very much for your attention.
Thanks, Bert. The last speaker, Rui Martins, will introduce the Living Energy Lab that consists of connected living buildings equipped with room controls and sensors. Rui is the Research and Development Program Manager at Smart Energy Lab. Please, Rui.
Okay, so good afternoon, everyone. Start sharing the presentation, and thank you for the previous speakers for interesting presentations. So I will introduce to you our living lab, the living lab that we have developed here in Smart Energy Lab. Our living lab is called Living Energy. And the idea is to not only introduce you how it works, how we implemented it, but also the advantages of having a living lab like this working, and all the potential that we can extract from this living lab. So first of all, why did we create the living lab? The idea is that despite all the technology that exists nowadays and all the concerns that exist regarding energy transition and climate change and everything, there's still a gap between having access to those technologies and implementing them and extracting the most potential from them. So we started the Living Energy because we wanted to develop this human-centered approach. So this allows us to be more close to the users of the technologies and of the services, and we want to be there very close because we want to understand what are the bottlenecks, what are the barriers that exist, and why is it that a certain service or a certain product is not reaching the market as it was expected. So this is also a way to engage real users, to understand more in deep their behaviors, to understand their needs. And what it also allows is to accelerate the adoption, because it allows to fine tune any kind of service or product that we are implementing or testing. And this fine tuning goes in the direction of the needs of the end users, and that's why it gets more interest from the end users. This Living Energy is a living lab from real users, real homes distributed all through Portugal, and it leverages on real life data so that we want to test and co-create these innovative solutions with not only the end users, but also with the providers, because providers have here a platform where they can understand the bottlenecks and the failures of anything that they want to bring to the market. I'll try to put a video now, if possible. I don't know if... Can you hear some sound? No, at least it's just back sound. But the image, I think it says it also. It's the distribution of the houses that we have, connecting portal. How do we do our installations normally? in a very resumed way, this video describes the approach that we have on implementation of living energy. So we have around 60 explorers nowadays sending live data to our backend. We have more than 600 sensors and meters, and so we have a lot of data also. Next slide. A lot of data that we are gathering and that we are analyzing and testing at the same time some approaches. So this systemic approach allows, like I said before, to engage the real users, to better understand how do they use their products and how do they contact with the services that are being offered to them. This allows us to gather a lot of data in a very detailed manner, and it allows also to have this feedback loop, because this is going back to the developers of the service or of the product itself, and it allows you us to surpass some performance barriers and reach even more better results for the end users and better results for the technology providers or service providers, like it says there. So in the end, it's all advantages. We have this very closed interaction with end users and allows them to tell us very specifically their experiences on a daily basis, what is happening on their house. So we also addressed some challenges to them, sometimes on a daily basis, that allows us to understand better the data that we are receiving on our backend. And this kind of approach, this is just one picture showing ways of the explorers that we have to interact with us and us with them. So there's a lot of ways that we are gathering data, not only from the meters themselves. And talking a little bit about the portfolio that we have nowadays. So like I said, it's around 60 homes being monitored. These are the age ranges. So we are not only having people that are on a range of working class. So we also have retired people being monitored. We have apartments, majority are apartments, but we also have residential houses, dwellings, and we have different types of meters, not only on the mains meter, but specific appliances like you saw in the video. We are also monitoring the heat pumps, solar panels, everyone that owns electric vehicles. We are and that are part of our portfolio are being monitored there. So this allows us to understand and analyze many data coming from these explorers. What then also allows us, all this data set that we have nowadays, is to start clusterizing the types of users, which will also be very helpful when designing a product or a service for a given type of end user, which is this profiling of people. In terms of monitoring equipment, this is the challenge that was also addressed regarding this presentation. So like you saw in the video, we have the sensors installed in different places in the explorer's house. And what we are using, it's on some or the majority of our explorers, is sensors that are also being used in the Smart2B project, which are some of them are the EDP ready EMS. So we have installed normal plugs, metering plugs. We have the ready meter, which is metering the mains. We have the solar plugs, which allows us to monitor the solar production. We have the AC plugs. These are special plugs because they have an infrared sensor and allows to send set points for legacy air conditioners. And then in the center, you have the ready gateway, which receives, compiles all this data and sends it back to the cloud. So this next image allows you to understand a little bit more. Normally, the ready infrastructure works this way. So you have all the data being gathered by the gateway, and then it sends it to the cloud via each explorer's internet, and then it's gathered in the EDP ready servers. But what we are doing on the Living Energy is that we are receiving data directly from the Ready platform to our Living Energy database, and we are processing, and then it's used in different ways. One of them is to visualize it by the explorers on our portal, which is the last part of my presentation. So we have this working portal, this Living Energy portal, where everyone can, similarly to the previous presentation where you have this app that Bert just showed, you can extract all these results from your daily activities, from your consumptions, and you can look specifically into your dishwasher, how was it consuming during the past week or whatever. And this also allows every explorer to have a more detailed picture of how are they reaching a certain type of consumption and why and when is this happening. Sorry. One other thing that the portal also allows is this very close interaction with the explorers, because it's the place where we pose also challenges to the explorers so that they can fulfill certain activities or turn on or turn off certain appliances at a given time of the day, which by participating in these activities, this provides some incentives to them, being vouchers or anything that after completing the activities they can access this kind of vouchers. So like I said, it allows you to have a real-time monitoring of your consumption and do different types of analysis of all the consumptions on an aggregate way or a disaggregated way in terms of the plugs that are installed. We don't have yet the service of automatic disaggregation like Bert just presented before, but this is also where we are heading to. So, and on and all, this is Living Energy, and I hope you like it because it's my last slide. Thank you very much.
Thank you, Rui. So this was the last presentation. We can now move on to the Q&A session. We already have some questions for the speakers. I would start following the order, if you agree, and we'll start then with Marco Martellacci. Marco, we have a question from Joao. Watch out, you are muted. So to answer, Joao is asking you, since the overall Smart2B ecosystem comprises a smart service layer, what is the main advantage of implementing and developing edge computing also in Smart2B devices?
Edge computing is a very important layer to guarantee an intensive frequency of regulation. Also, if there is a failure of the connectivity, you can resolve this part. It's important also have a safety control. That is the control that happens when there is a critical condition, and how can I say, it guarantees a safety for the equipment. So the edge computing, it's very important also to reduce the cost of the connectivity, because if you have system identification that you know your HVAC system, You can also predict what it happens, and so you don't need to receive every time the commands from the cloud.
Thank you, Marco. We have another question for you. This is from Ana Ferreira, who's asking, what is the main applicability and advantage of e-wearable when compared to e-sense?
Yes, the wearable is one main idea that the wearable is a portable sensor. The guarantee that data is your own data. If you fix a sensor or sensor in one room, the data is the owner of the data is the owner of the building. If you have a sensor that can allow you to measure the air quality in each building that you can visit, you can share this data, and you can also use these appliance to send a feedback of your consideration of the air quality in the building.
Thank you. We have a question for Bert. That's from Miguel Brito, who's asking, do you also use the analysis of smart meter and real-time data for flexibility on the grid, or are you mainly focused on the benefits for the consumer consumption?
No, we're identifying switchable loads. So in a lot of regions, especially in the US, there is time-based billing. So there are flexible rate plans, and giving customers insight in what their flexibility is and how their consumption patterns are actually matching the flexible rate plan is helping them to change their behavior. Another example of this is behavioral demand response. So with E.ON in Germany, we have developed a happy hour service where in the market, if there is a lot of renewable energy in the market and the energy price is low, E.ON is giving their customers a rebate on the energy price, and we nudge customers in real time to consume more energy. And this is a huge success.
Thanks. We have a couple questions more for you, Bert. One is from Diogo Gomez. In your opinion, can neural networks play an important role in predicting events in the energy field?
We don't use neural networks that much. We use so our models on real-time data are bespoke models that we train. They're more working like image recognition, where our models on 50-minute data are machine learning models. We do use neural networks in some of our embedded systems. For example, our clamp-based solutions, where we have a 3-phase solution, and we do a current voltage matching between the voltage that's measured on 1 phase and the current that's measured on 3 phases through a neural network.
Thank you. We also have a question from your fellow speaker, Rui, who's asking, how is the appliance database accessible to others?
It is not.
Okay, thank you.
Okay, so let's pass to the next speaker. Rui, we have a few questions for you too. This is the first one. What is the main purpose of the Living Energy Lab, and how do you think the real data that you have been acquiring in the Living Energy could be used to develop new devices and services?
So the purpose, it started, the idea was to test and validate our own product and services. So it's being used primarily for that, but as the time being, we are also selling this Living Energy as a service. This allows others to test their own possible services inside the database that we have from our portfolio of explorers. And at the same time, the type of portal and the services that we have just on the portal side are also being sold for other companies that want to implement likewise visualization and capacity and analysis capacity.
Thank you. We have another question for you, Rui. This is from Ana Ferreira. Do exploradores usually visit the Living Energy portal to see their data?
I think that not all, but averagely, I think on a weekly basis, they visit the portal, and the number of visits increase whenever we pose challenges, because these challenges are what drives them also to the Living Energy, to the Living Lab itself. And this is what allows them afterwards to receive those rewards for completing the challenges.
Great, thanks. And we have another one for you. This is from Diogo Cabral. Are the Living Energy users rewarded by their best practices in terms of energy consumption?
Well, like I said, on a daily basis, no, because this is what we are measuring is their normal habits of consumption. But whenever we pose a challenge, and if the challenge is rewarding the most efficient type of consumption or consuming up to a certain level, this is rewarded, yes. If it's inside the challenges, for sure.
Okay, thank you. We still have some time, so I would take advantage of it to have another round of questions. So I would go back to Marco. We have a question for you, which is, how do you guarantee the safety of data brokered by the e-gateway? Your mic is off, Marco.
Okay, thanks. Safety is guaranteed because it's implemented with the AWS that is certified by ISO 27001. So the safety is guaranteed.
Okay, thanks. We have another one for you, Marco, which is, how does the e-gateway connect or communicate with the Smart2B cloud platform?
The gateway is able to collect data from devices such as sensor, meter, wearable, and node, and communicate with the Smart2B cloud through the firewall broker component. That is a component that is placed in the cloud, in Smart2B cloud.
Okay, thank you. Bert, we have another question for you, which is, can you explain a little deeper the hardware devices setup that you install in your customer houses?
Yeah, sure. We have about 15 different SKUs, so 15 different models to cover all different meter interfaces that there are around the world. And our devices are ranging from very small devices like this Eon Elna product. It's working on a P1 interface. We have the same product working on the Modbus interface that is used on Portuguese meters. We have products that work wireless, that work on LoRa, on Zigbee, Zigbee Smart Energy. We have optical readers, and we have clamp-based solutions in different models. So in a DIN, like a half a DIN form factor, single and three-phase, but also that go into metering cabinets that are placed on the outside of the house for Australian and US markets. So basically, we cover the HAN port of meters, so the home area network port of meters in all countries. The hardware itself, it's all based on the same chipset with both Bluetooth and Wi-Fi on board of the same chipset, which means that the installation for the customer is as easy as installing a Google Chromecast. The installation is like a 2-minute job. And we stream, after the product is connected to home Wi-Fi, we stream data to the cloud platform. And the data will, because there's a web server running on every hardware, the data will also be available on a LAN API for third-party solutions. Besides this aggregation in cloud, we also have edge applications that provide distributed intelligence. So we have disaggregation models that run in real time on the edge without an interaction with the cloud to detect certain events in the house in real time. Does this answer your question?
I guess so. I think it's. I think
if you go to our website, netogrid.com, and if you select the hardware section, you get an overview of all the different models that we have.
Thank you very much. I have another question for you. Since Net2Grid is already on the market and have a lot of experience, what do you think about the openness of the market to complete smart ecosystems like Smart2B, which include devices, platform, and services?
That's a question more leaning towards interoperability. I think interoperability is very important. I've always been focusing within Net2Grid on following interoperable solutions, because the energy transition is a very complex puzzle, and we at Net2Grid are only creating a little piece of the puzzle. So collaboration is really important. To share the data for home energy management systems, we have integrated in our product, so in our gateways, a IEEE 2030.5 client. So we can interface using that industry standard with other energy services in the home. And on the cloud side, our services are API-based with OAuth 2.0 access control. Our API documentation is, we are an API-first company. Our API documentation is on our website. So it's open for any developer to develop against.
Thank you, Bert. Okay, we have a few more questions for Rui before concluding this webinar. We have one from Diogo Ribeiro. How valuable is the data that you are acquiring? Are you planning to monetize the acquired data with benefits also for the exploradores?
That's a very nice question. So we are currently in European project regarding also the sharing energy data and European energy database that is going exactly on that direction. So this is a learning curve. So we're trying to understand also the value of our data, the ways that we can possibly share it and to monetize this data, and also the means of pushing this value back to the data provider itself. Because if this goes to a big pool where other companies can bring and test their own services and develop new products, this creates value to them. But the idea is also to bring some of or part of that value back to the original data providers. So yes, and we are also defining some other use cases where we can directly not sell data, but sell possibilities of exploring that data and defining new services.
Thank you. Another couple of questions from Ana Suarez. Rui, how much effort is required from the end user perspective to independently manage their loads using the controllable plugs?
Well, we have the controllable plugs, but nowadays we don't offer yet that option of the end user to control these plugs by himself, because this is something that we are planning on a type of service. When we will offer this possibility for the explorer to control their own plugs, we will be extracting and learning with that data and understanding how these interactions occur, because this will allow us in the future to automatize those needs and those set points being input by the explorer himself. So, and also this brings us to the question of, in the future, some demand response schemes where we can develop, and we aim to develop some services on that streams.
Thank you. The last question is, for the global consumption, do you use the HAN port in the smart meters?
Nowadays, we are not using the smart meter data. We are using our own metering data, because the interaction with the AN port has some bureaucracy and some steps. And at the same time, up until now, we have tried, we have defined the path to use the AN port and go to that way, but nowadays we are not yet using it.
Thank you. So this was the last question of our list. I thank everyone who participated to the webinar, and of course I thank also the speakers for the very interesting presentations. There will be more webinars, as we said before, since we are talking about a series of innovation webinars hosted by Smart2B. The next one will be in the next few months, and of course you will hear from us regarding that. So thank you again, and we will be releasing the video recording of this webinar in the next few days. So follow our channels in order to be updated. Thank you very much.
Thank you, Fulvio.
Thank you. Thank you all.
Thank you.
Good evening. Bye bye.
Bye bye.